everyone. Welcome to Risk Roundup. While blockchain technology that uses cryptography and a distributed messaging protocol to create shared ledgers among counterparties brings transformative potential and benefits to nations and all its components, is being hailed as one of the most revolutionary and disruptive technological advances of today, it still faces many complex technical challenges. So, what are these technical challenges, and can any of them be addressed through the development of blockchain standards? To discuss the technical challenges facing blockchain and the need for blockchain technical standards further, I'm delighted to welcome Rob Hitchens to Risk Roundup. Rob is a blockchain advisor and is based in Canada. Welcome, Rob. We are honored to have you on Risk Roundup.
Thank you for having me. It's a real pleasure to be here today.
Wonderful, Rob. So, across nations today, there are thousands and thousands of startups and innovators that are coming up with new ideas of using blockchain technology to disrupt nations and all its components, and they're coming up with really good applications initiatives. So, while the blockchain technology has transformative potential, and despite the great excitement in the startup community, what are the concerns regarding the technology that is still preventing its widespread adoption?
Blockchain is widely recognized as a potentially potent and disruptive principle. I think we're in the early stages of exploring the potential applications and optimizing implementations. I'd even say that blockchain enables new possibilities, and this means carefully considering what we should even want to use it for.
Yes, that is very true. That's exactly the key question that each innovator or each nation or each component of a nation needs to ask, that why do we need to use blockchain and where can we use blockchain to come up with effective solution to the current problems of the systems that we are facing across nations. So that is a very good point that you made there. So as we evaluate the current state, what are the technical problems with blockchains that prevents them to be limitless or free of deficiencies, weaknesses, and vulnerabilities, or it prevents them to be scalable? So, what kind of technical challenges do you see innovators facing all across nations?
Well, my goodness, that's a lot to unpack. I don't believe that mankind has ever produced anything widely regarded as limitless and free of deficiencies or a perfect piece of technology. And this is partly owing to the limitations of our technology, but I would also argue that usually there's no consensus about what perfection would even look like. So, for example, blockchain brings the issue of trust to the forefront. Architects conscientiously place trust where they think trust should be. And there's a possibility of replacing processes and organizations with more trustworthy machinery. And some people find that very desirable. Others may be very leery about the possibility of removing human oversight. So this leads to some very interesting discussions about the ideal approach to any given problem domain. It's not uncommon to find the challenges ahead are philosophical, sociological, and ethical, as well as technical.
Yes.
I feel I would be remiss if I did not stress that if one wishes to induce others to place 100% trust in an immutable piece of software, then that piece of software requires the utmost care and attention to detail, and the burden of proof rests with the people who encourage other people to trust software completely.
Yes, I hear your point, and you made an excellent point, because I hear this question, wherever I travel also. People say that, these smart contracts are emerging, and the code, the algorithm that is behind that is bringing so much trust. And I think about it, and I tell them that, I mean, specifically talking about smart contracts, that it's a contract management innovation. So in initial, I mean, currently we are using paper and pen to, sign contracts, and we have a whole ecosystem around it that that is giving the trust to everyone who is a part of those contracts or who is signing the contract, that those contracts will be valid, and those contracts are going to be honored by the ecosystem that is within that nation. So just by replacing that paper and pen, and just by changing how we write contracts, and we are, instead of paper and pen, we are now trying to use computer algorithm, the entire ecosystem around that doesn't disappear or doesn't become obsolete. We still need an effective ecosystem that can provide trust, and that means that we still need the human factor involved in each of these transactions to give effective trust. So both these points that you made about the trust, as well as the uh, you know uh, human factor, that I still feel that even though we may change the way we do a lot of things, that humans will still play an essential role for many of these new systems that we are trying to redefine and redesign. And that's where the trust will be able to originate, that yes, there is someone behind the scene, or there is someone who is going to be accountable, who will be honoring these transactions as it happens, because we cannot see the computer code, we don't know who is behind that. So it is going to be extremely difficult for anyone to just trust those kind of transactions, where we don't have an effective structure, framework, and systems and human factor involved. So you made a very good point, and I think there is also this the primary design structure of many of these existing system is a linear linked style blockchain. So I believe that as adoption increases of blockchain technology, and as we try to develop more applications, many more miners will be attracted to the system, depending on how the blockchain system is designed or blockchain application is designed. And that's where many of the scalability challenges will come in, because of the way these algorithms, and because of the way the blockchain technology is operating right now. So there are a lot of complex challenges emerging, and as a first generation blockchains have established a base programming ecosystem, but the question is whether that is sufficient for the applications that are emerging. Do you think it is sufficient with the current parameters that we have around the blockchain technology?
Well, okay. there's a fair bit to unpack there. I think maybe if I can break it down into a few separate concerns here. I've never personally been a big fan of the term smart contracts, because it just seems like a phrase that was around at the time. From a marketing standpoint, it's been very successful. It's catchy. People remember it. But the fact of it is that they are not smart. They are they're machines, and they're idiomatic in design, and they're not contracts in the legal sense of the word. Also, they're computer software that doesn't generally naturally map to the way that, say, a legal contract would be constructed, and they map more in terms of how one would describe a stateful network protocol. So it's a long way from a legal contract, but there's a few things that have everyone excited. One is that for thousands of years, I think at least centuries, contracts have been sealed with a signature, which is basically a squiggly line on a piece of paper that supposedly only you can replicate, and it's kind of quaint. And we have at our disposal now very, very solid cryptographic, mathematical, well understood, well proven systems that are very strong signatures that show that, okay, someone signed something and they have a property of non-repudiation. So we can be very sure that someone with a private key has signed a transaction into existence. Um, we also have, through blockchain, smart contract, there's that word again, these platforms, we have the ability to make serverless software. So these are stateful systems with no centralized storage, and we can release immutable rules into these systems and understand that these systems are going to keep executing without any further help from us. And this is really interesting to people because they see that they can look at a smart contract, understand what it does, and have assurance that no departure from those rules will ever be permitted. So that idea of certainty and assurance is very appealing on a lot of levels. I think we have struggled as an industry to find the vocabulary to describe this kind of stuff, and so terms like trustless have been tossed around. And it's not really trustless, but really what one is doing, in my opinion, is designing for where one wants to place the trust. So, for example, if there's an intermediary involved or an escrow agent involved, and one is placing their trust in an escrow agent, if one is putting their trust in a fully automatic system, then what is implied here is that one is trusting the machinery of that fully automatic system implicitly. And it turns out that in a lot of scenarios, we don't really want to place 100% of the trust in machinery. There are very good reasons for wanting some measure of human oversight, the ability to intervene, the ability to deal with issues like probate or court orders, that sort of thing. And so what we end up doing is talking about the degree to which we want to reintroduce some degree of re-centralization in order to make a solution that's suitable for all.
Yes, absolutely. You made a very interesting point that even though our efforts are towards decentralization and we want to remove all the middleman, we still need some sort of governing structure, because there is always going to be issues, no matter what kind of system we are trying to redefine or redesign, there needs to be a governing body. Otherwise, if you see the blockchain, that 51% rule, I mean, we all know that if 51% of the miners, try to enter wrong information, wrong data in it, then it will become, that wrong information will enter into the system as something valid, and it will be very difficult for us to overturn that or change it. So there are a lot of serious drawbacks of just trusting the computers or miners. We do need to come up with some sort of oversight so that we can prevent those kind of issues emerging from the system, the technical challenges that we have with the blockchain system currently. Now, although the adoption of this blockchain technology promises so many benefits with regard to, I mean, it will make our systems very productive, efficient, and very quick in how it responds to whatever task is on hand, and hopefully it will reduce cost. There are some growing concerns that it is becoming expensive. uh, the transaction cost is increasing, as well as that it is very expensive to initially put blockchain software in place. So what is the reason behind that? Why is it so expensive to build a blockchain system? If, let's say, any corporation wants to, or let's say industry sector wants to redefine how they are doing certain things, that it's very, very expensive for them to put together the whole system.
Again, there's excuse me, there's a lot to unpack there. I don't agree with all of the assumptions, but I think this because we're making some broad generalizations here. Um, it might be helpful to think of a given application space in terms of what needs to be proven, and who needs to prove something, and who do they need to prove it to. And what I in my work at B9 Lab with students, one of the things that certainly for the maybe the first third, the first half of the training. Much of this is about breaking down the assumptions that they bring from experience with server-centric systems, because it does not make sense in a paradigm of thinking of these systems as a one-to-one replacement for server logic, or a one-to-one replacement for database, or a one-to-one replacement for traditional storage. This is something entirely different. And what the systems are based on proof, and they are based on proofs at a very, very fundamental level. And then blockchain systems build up proofs to more abstract and elaborate constructions. But it turns out that when we talk about what do we need to prove, and who do we need to prove it to, it turns out that the whole scope of the application generally does not rise to that level of requiring proof. And so we say, well, we can accomplish all of that kind of stuff with traditional technology. So there is, for example, a strong case to be made that when it comes to the money itself, and I would say I don't like always referring to Bitcoin, but it was first and it's the most well known, right? People don't want human oversight. They don't want the money in their pocket to simply vanish. They want it to be censorship resistant, and they want it to endure, and they don't want a system administrator to have any power to intervene over that. So it was designed specifically to be free of governance. And if that is a design goal, then that's how you design things. And there are examples of that in the world of smart contracts and other scenarios where we say, no, the actual correct way to approach a given problem is to not vest that type of authority in anywhere in particular. In other cases where we do want human oversight, then what we end up doing is saying, well, these things that would, at a company-owned system, we would give that to the system administrator, and that would be the end of it. When we're talking about systems that are designed to prevent the formation of concentration of an imbalance of power, if you like, a group of trading partners or nations or banks or what have you, if they do want that ability to intervene, for example, okay, then what they end up doing is designing a governance process that's agreeable to them. And then what ends up happening is that governance process itself, how is the committee formed, how does secession work, et cetera. That's what ends up getting codified in the smart contracts, so that it's like a constitution, if you will, so that no departure from the governance process is allowed. And this gets very elaborate because it may include such factors as how do we upgrade the governance process itself? So what if we're not smart enough to anticipate every possible future scenario that we want to be able to react to? In that case, then how will the members agree on an update, an upgrade of the protocol itself, or an upgrade of the governance? How will we amend the Constitution? And these are really interesting things because as software designers, we don't typically get into this realm, but blockchain systems that are involved in it's really about Alice wants to prove something to Bob, and Bob needs Alice to prove, Bob needs to prove something to Alice. And the easiest model to think about is an escrow agent or something that solves the problem of Alice and Bob not knowing each other. In the case of disintermediating that exchange, right, then things have to rise to the level of being proven. Now, in a simple sense, you can prove that if Alice and Bob are money, then Bob will send Alice the security. The end. Right? Very simple. In a more complex arrangement, one might have to prove that a similar exchange takes place, but also very transparently, where everyone can see it, is a body of human oversight and perhaps individuals who are accountable, and a policy that says that we will intervene in the case of probate or court order or something of that nature.
So, based on your understanding, what you have seen, is there an ideal example of a smart contract where you have seen the effective integration of the laws of that particular industry or that nation, and that that it has been scalable? Has it been effectively implemented? Any of this smart contract, the integration of the laws of that particular nation?
Oh, I think we're way ahead of ourselves because the laws of nations are quite complex, and that would be a big that would be a big project. I would say that what you would see are systems of exchange and other applications where the some measure of accountability and centralized control is there. A very popular pattern is for people to create something on a public network and say that initially the creators will have stewardship over certain parameters that they're not certain about how to calibrate over the long term, and perhaps a roadmap for replacing themselves with a governance process over time. Other cases at a platform level, you have things like EOS, like Corda, the Hyperledger projects, etc., that are meant to be used by parties who come together where there already is trust, where the say a network of banks come together and they already recognize who's who. So anonymity is not an issue, and they can say, okay, we're going to start with governance and then and build on our application from there.
Yes, that makes sense. That makes sense. So now, in for any industry or any corporation, for them to make a move to a blockchain-based system, they will either need to completely overhaul their previous system or find a way to integrate their existing system with the blockchain solution. So, do you see that the blockchain at this point is able to or will be able to handle all the business functions or industry functions needed by the corporation, organization, or industry, whoever is trying to do those changes?
Well, I think these projects need to be evaluated on a case by case basis. I personally don't believe there should be a crusade to blockchain everything as soon as possible. I think you look at a specific application and you say, okay, does this save money, and or does it open new business opportunities? So, for example, Accenture has looked at the insurance industry and have looked at the just internal uh, the work process of processing claims, adjusters, etc., and figured out you might have about a 15% improvement without radically redesigning anything. It's just taking the process that's already there and go fast. Turns out worldwide that's a multi-billion-dollar a year solution. So that's very compelling and it's actually non-disruptive. Uh, at the end of the spectrum, you have entirely new things popping up, and a lot of this stuff is experimental. And I would I try to stay away from future forecasts, but I think I'm safe to say that most of the experimentation won't work. But occasionally you get something like what Uber did to the taxi cab industry, and that is not simply taking what was there before and making it go faster, but rather imagining an entirely different business model uh, based on different structures that this kind of technology can enable.
No, I understand that. It makes sense. And I mean, there are a lot of concerns emerging that it probably will be very difficult to eradicate the legacy systems. I think that's one of the problem that many of these industries and corporations are facing, that and it makes sense that it won't be possible to completely probably eradicate legacy system. It will have to be a phase wise approach. Maybe down the road, after in a decade or something, we'll be able to reach that endpoint, but at this point probably we'll not be able to eradicate legacy systems and be able to put all of our business processes on the blockchain. So we'll see, as time goes and as more experiments are done and more applications emerge and more innovators and startups try to solve these problems, it will be interesting to see how they solve these complex challenges. But there is also another concern that any of these consensus mechanism on blockchain, there's a huge amount of power consumption for any of the blockchain transactions. So how much power do you see that an average blockchain transaction require for it to conduct, irrespective of whether it's a blockchain within a nation's boundaries, or is it, it goes through across nations boundaries? What are the variables that impacts the energy consumption or the power consumption?
There's a bunch going on there. When I look at the different blockchain platforms, basically what has happened is it's as though we've discovered electricity or we've discovered fire. It's quite useful. It's not useful for all things, but it is multi-purpose. When Bitcoin first came out, it was the first, and basically the principle that was demonstrated there was that a vast network of computers that do not know or trust each other can nevertheless reach a consensus about something very important, and they can do that in a very convincingly reliable way. So this eventual consensus it's strong enough. It's strong enough that you can have hundreds of billions of dollars locked up, protected by nothing but the blockchain principle. And that's really interesting because it's strong enough then that it can stand in as a substitute for currency. And I sometimes describe it as this will turn your world inside out, because blockchain truths are like factors in the environment. It's like a big spreadsheet in the sky. You look up and you see the moon and the stars and a few things like that. And people who don't observe the same things that you see are not simply a difference of opinion. They're just wrong. The first demonstration of this principle was based on brute force and a majority. So the idea that an attacker cannot distort the facts. And as with any fault tolerant system, it has a known threshold where the assurances begin to fail. In this brute force proof of work system that Bitcoin uses, the failure point is when the requirement is that a majority of the nodes have to be honest, right? So 49% of them are under attack, or 49% of them are in collusion and launch an attack. This will not work. But when they get a majority of the network, then all assurances are gone. But it actually is not quite that simple in terms of security, because the other 49% of us are going to notice that this happened, and we're going to notice that there was this coordinated attack. It would be very hard to conceal such a thing. And we're under no obligation to pay any regard whatsoever to the attack. So even in the case of a 51% attack, the odds of actually getting away with anything valuable are practically zero, because the other 49% of the people will just decide to, well, let's ignore them. They're all criminals. We're going this way and following the truth. So it's not even the actual attack vector becomes even harder to visualize. Now, I would suggest perhaps inadvertently the mining process has resulted in industrial scale mining operations, because what proof of work basically does is use brute force computing power as a substitute for accountability. So if it wasn't for the unaccountable anonymous participants in a public network, right? If there was accountability, then there would be no need for proof of work. And there would be no need for a Bitcoin because there would be no need for a financial incentive to do the right thing. And there would be no point to a financial punishment for doing the wrong thing, right? So the network needed this to coordinate everybody's activity economically and say, you should all go this way and do the right thing. What that has done, and I really don't think this is on purpose, but it has inspired the construction of ASICs, for example, that are dedicated to solving this problem. And it has created mining that migrates to wherever it can find cheap and plentiful electricity, because the critical success factor is cheap power. So what you end up with is you end up with quite large mining operations, like many like large. Um, but I think that gets headlines and maybe may seem a little bit alarming, but again, unexpected consequences here, and I take a more positive view to this because what it's actually doing is it's mostly migrating toward those areas where there's excess power that would otherwise be dumped, and saying, well, here's a way to monetize it, and it's inspiring R&D in novel areas like waste heat recovery, waste energy recovery from all kinds of processes. It basically says, here's a shortcut to monetizing whatever you can do. So now you have people exploring all kinds of energy recovery systems that they would not normally do because they would not be able to find market. Mm-hmm. Now they're able to say, yeah, I mean, as long as you can make the wheel go around, make electricity, then you plug the Bitcoin miner into it and money comes out. That really simplifies matters considerably. The other factor is that people who've seen the formation of these consensus mechanisms have realized that maybe proof of work is not the only way that similar assurances can be achieved. And one of the differentiating factors between all the different blockchains out there is how they achieve a consensus, what algorithm they use to achieve a consensus. And most of them, I'd say a majority of them, are reintroducing some factors of trusted actors or trusted validators, things of that nature, to make the system go faster. Or, for example, in Ethereum, they're experimenting with proof of stake, which is basically substituting a financial bond that is bound to good behavior. So basically now instead of brute force, what you have is everybody in a room and people put up a bond that, for conversation's sake, think in orders of magnitude upwards of $100,000. And you have every other witness in the room observing every move. And every time the node makes a move which is not in agreement with the rest of the room, they slash the stake. So there's an immediate financial punishment for not following protocol.
Yes. Yes.
And this is very efficient.
Yes, I believe you, because I mean it's not necessary that we go through the mining operations only to get that kind of consensus. The proposal that we have put together, it's also involves, there is no mining involved in that. It involves security council layers at different levels depending on the nation and what kind of risk that is we are trying to manage. So there are, like you said, there are many different ways, but the biggest challenge, is to how to bring accountability into human action and decision. And that, even though there are many ways to do that, to make that as a embedded into human behavior, that is the biggest complex challenge we are facing. And I'm sure that we are trying to, by giving financial incentives and all kinds of different processes that we are coming up with, we are trying to change the human behavior, but it's still going to be very, very difficult going forward. But let's move on to talk about the what is the role of the network size? Because it's said that there are many who say that large number of users are essential, or miners are essential for any blockchain to be effective. So, from your experience and your observation, what you have seen across nations, how critical is the network size for blockchain based system to be successful?
That depends on the consensus mechanism. So, for example, you can have a very successful private network with with millisecond transaction times and very high capacity. Um, And the way you might do it is you might say that all the banks, maybe they're even co-located at the same data centers. They're all going to have low latency connections between each other. And the minimum threshold for participation is a lot of RAM, a lot of firepower so that you don't slow the network down. And effectively, you can approximately go as fast as you want. You also don't need a large network because you have accountability, and they'll work on systems such as a validator at each participant in a round robin process, and for example, or Byzantine fault tolerant systems, or any misbehaving node will simply be ejected from the network. There's really no minimal critical mass for such a thing. It'll just work. Um, in the public networks that rely on proof of work, then no question, the more participants, the more computing power is involved, the higher the threshold for a 51% attack. That we always comes back to what 51%. Well, I need 51% of the firepower. How much is that? Well, it's 51% of whatever's there. So the bigger the thing that's there, the larger the scale the attack would have to be. So small experimental networks that rely on proof of work are very vulnerable because actors with a lot of compute power can come along and push them around, if you like. But then again, networks with the kind of proof of work power as Ethereum and Bitcoin, for example, brute force would require considerable effort.
Yes, yes. Now I hear you. You make a good point there. Now there are growing concerns. Let's talk about the cost of each transaction on the blockchain. I mean, for people say that for some time, Bitcoin and all that, there was, the transaction cost was almost none. It was almost near free, for the first few years of its existence. But now that, the transaction costs are going up, what is the reason behind that? Why is the transaction cost going up?
Well, one of the things that is perhaps a little bit counterintuitive, at least it was to me when I first encountered Bitcoin way back in the day, was I intuitively thought that as the network grew, it would increase in capacity. And what I subsequently discovered was that performance doesn't scale with size. Its resilience scales with size. Its performance is stuck at a finite number of transactions per second, and it's not going to increase no matter how much hardware is thrown at it under the rules of the current protocol. And so basic economics says that value or funds flow to whatever is scarce, and there is a scarcity of carrying capacity at the transaction level that's built in. So there are all kinds of surrounding scalability solutions around that. But what you also see in parallel to that is at the time that people were talking about Bitcoin transactions being nearly free, they were also talking about Bitcoins themselves being nearly worthless. And nowadays, if someone, well, the folklore says that someone paid 11,000 Bitcoins for a pizza, so that was a very expensive pizza by today's standards.
Yes. Yes,
No.
it would be.
Yeah, and so there are lots of we have a similar thing going on with Ethereum where transactions are processed according to the price of a transaction is the computational weight multiplied by the bid that the user attaches to the transaction. So this is the user's way of pricing the priority that they wish to associate. So big transactions cost more than little transactions. But then the other factor is what are you willing to pay for compute? And during periods of congestion, this is the solution. So the price of a transaction increases a little bit. And if your transaction is for a pack of juicy fruit and it's not especially important, then you say, well, I'll put a low transaction priority on it, and maybe it'll finish by tomorrow. But on the other hand, if it's a very important transaction, then it might be worth bidding up higher to get the priority so that it gets mined in the next 15 or 30 seconds. So it's a supply and demand thing. I personally find it quite remarkable still that for a few dollars, I can publish a smart contract on the Ethereum network, and there's no OpEx, there's no server requirement, there's no infrastructure requirement. It needs no further help from me, and it will run forever.
Yes, very true, very true. It is very fascinating. Now, there's also, I mean, I wouldn't say it's a concern, but what is the network speed, average network speed for the transactions happening on any of the blockchain? We are not talking about any single blockchain like either a Bitcoin or any other for any specific industry use. And how many transactions on an average can a blockchain process per second?
Well, I think one thing to understand here is that this blockchain stuff is never going to perform especially well as compared to a traditional database. It's just not built for it, and it won't win. But having said that, the transactions range from the slowest being 10, 20, 30 minutes or so for a Bitcoin transaction to millisecond timescales on private systems.
I see, I see. Now, there are the majority of blockchains, I believe, use proof of work, right? I mean, in order to achieve consensus. At this point, we still see that. I mean, as we discussed before, there are some in emerging new ways of doing that consensus mechanism instead of mining, but it's still the proof. They all need to achieve consensus. So, proof of work involves the use of computational power if they go through the mining process of a machine to solve complex mathematical equations in order to verify a transaction and add it to a block. Now, while this mechanism works well, as is witnessed in, as we have seen in Bitcoin, it works really very effectively. And we talked about it that it does consume a lot of energy. So, do you see that one of the reason why blockchain is not widely adopted, that it is that energy consuming mechanism that is becoming one of the obstacle and challenges?
No, I do not.
It's not.
No, I don't think the average user is. Uh, Sorry, I have multiple things flashing through my mind here. First, I don't think the average user is concerned about the validation, electricity consumption, for the same reason that I don't think my mom is especially concerned about the nuances of wide area networks when she talks to me on Skype. It's there, but she doesn't know about it. So I don't think that's the make or break reason why anybody uses this stuff. The second thing is that it's the transaction costs and the power are actually not bound, and there's no ratio there.
I see.
You can have 90% of the miners drop off because it costs more to mint a Bitcoin than to the electricity, and then it can crash. Price it doesn't make any sense. It would turn off the machines. The Bitcoin network simply shrink in terms of the proof of work threshold to the 51% attack. So transaction capacity will change.
I see. No, I hear you on that. Now, uh, do I mean we everything is moving towards a mobile like, platform, right? I mean, smart because of the smartphones and smart equipments. People are trying to develop applications that are effective, on mobile as a mobile application. So, do you see that? There is a trend going towards building smart contracts that are mobile friendly.
That's mostly a user interface concern. So, I mean, not every application is public facing, but I would say that apps that are meant
Yes,
to be
of
public
course.
facing, then yes. I think there's some work to do to make that stuff a little bit easier. Um, I like to say that this will really be user friendly when my mother can use it and not realize that she's using a blockchain, and she doesn't realize that she's using Ethereum, right? When she does, so when the tool stack gets a little bit more transparent, just kind of built in, it'll be a little easier because it's a little bit on the clunky side, but it certainly works.
Yes, very true, very true. So, I mean, irrespective of whether it's a private blockchain or public blockchain, whether it's permissioned or permissionless, I mean, private key and security and privacy, all these aspects needs to be there needs to be education and awareness for each and every human who is trying across nation, because if everybody is supposed to be that comfortable, then the security aspects and all these technical understanding also needs to be part of that. So I think it will still take a time, probably years, before we can see that kind of widespread adoption and widespread comfort of using this or accepting of this new way of doing things. So having said that, let's move towards talking about the blockchain standards, need of blockchain standards, and what kind of concerns or complex challenges, especially the complex technical challenges, we can solve by developing blockchain standards. So from your assessment, do you see that there is a role for technical standards in supporting the global rollout of these blockchain technologies, or do you see that we have optimal technical standards and framework to support the rollout of blockchain technologies at this point?
I'm a big fan. I'm really pleased to see the emergence of technical standards. I think that uh, security and regulatory standards get a lot of headlines around a very narrow band of investment related things that happen to be uh, deployed using smart contracts or blockchain technology. But as a technologist, I tend to focus more on things like, does it work? And it's very important that it works if it's an immutable piece of software and it's going to uh, be responsible for non-trivial amounts of value or non-trivial consequences in the real world. So it needs to work. So at B9 Lab, in our work with students, we really try to instill a sense of conscientiousness and respect and caution. And another company I helped get started called Solidified IO is specifically focused on quality assurance. I'm a big believer in public, transparent, peer-reviewed code review, system audits, testing. The burden of proof really is on the developers to show that they have adhered to all known best practices, that multiple teams have looked at the software, and the software is fit to be trusted with the purpose that it's intended to be used in.
Yes, very true. So from your assessment, which are the top five or top 10 technical problems you feel that we do need to solve using the blockchain standards?
Problems in the world in general with blockchain,
Yeah,
or
with
problems
blockchain.
that surface inside the contracts?
Uh,
You mean like
we are not
with the
talking
focus
only
on defects?
Sure. I mean, we are not talking only about the smart contract. We are talking about overall blockchain development, implementation, acceptance. Anything that could, anything where the technology could be a problem. That there are still some variables in technology. There are still some inherent technology problems that could be preventing the global acceptance or adaptability or scalability of the blockchain.
Well, the one that stands out in my mind is not actually a technical problem, but rather there is a mindset and a best practices policy problem, because it seems that, over the past few decades, the world has moved more and more to a rapid release cycle and moving, rapid release, move fast, be agile, break things. And there's a hidden assumption that software can evolve. And I think that with certain with this type of software, certain components of this type of software cannot be upgraded later. We need approximately the exact opposite perspective. It's not entirely foreign. So if you look at aerospace, for example, and if you're putting software on a Voyager spacecraft and shooting it off into space, you know that nothing is on board unless you put it there. And you have to think in advance, including how are you going to upgrade it, everything. You have to figure it out in advance, right? And it's not exactly compatible with a mindset that wants to rush things to market. Now, I understand that there are competing business priorities, right? So I usually find myself stressing the need to just pause and do quality assurance.
Yes, yes, very, very true. There are what we see as acceptance or adaptation or scalability that probably but in all of these different variables or concerns, there are always some technical challenges that still needs to be figured out for people, for users, for developers, for innovators, to for corporations to feel comfortable that it will bring us effectiveness and productivity. So I still feel that irrespective of whether it's privacy, security, interoperability, or any of these different variables, that there are still some things that needs to be sorted out. But having said that, who is developing this
There's a lot to sort out.
yeah, there's still a lot you are absolutely right, there's a lot to sort out, you're very right. So, who is developing this? Who is working on developing these blockchain technical standards?
You're welcome to join in. it,
Okay.
um, there really is a bit of a meritocracy and a bit of, I think, friendly competition. I think generally speaking, there appears to be a bit of an immune system that will reject any individual or any organization with an outside sense of self-importance. And yet at the same time, there is widespread enthusiasm for standardizing on many things. And that can be everything from everyone understanding the anti patterns that everybody must avoid, and good software design patterns, to getting together and normalizing on common issues like schemas for common things, or how are we going to do identity? How are we going to do governance, general purpose governance, all kinds of stuff. And in many respects, the leading projects are led by people who are basically out there saying we think that we might be able to build a standard to handle one little corner of the network.
Yes, very, very true. I mean, there are even if we just think about security, there are so many complex challenges. I mean, how do we do effective authentication, and how do we ensure that security of blockchain and all its irrespective of whether are in forks or irrespective of what application it is being developed on that we do need to come up with effective way of ensuring that there is security on the each of these nodes, and that no data is fraudulent, and that no, if people are using it for cryptocurrency, then that there is a legitimate we do need to come up with some sort of identity control so that we know who that money belongs to, because I think this anonymous way of anonymity for the money, who owns the money, nobody knows on this current crypto, most of the cryptocurrency uh, platforms that we see. That I think is a big security risk for each and every nation, because when we are trying to tell the common man that put your money into the cryptocurrency, and if we are trying to tell them that you be your own bank, then if they don't have enough understanding about how to control or how to secure their cryptocurrency, how to make sure that their private key doesn't go into wrong hands, or that their computer is not hacked. Even now, we even for computer literate, the security is such a complex challenge. So to expect that the common man, everyone would be able to protect their money in the cryptocurrency format, I think it is uh, probably short-sighted, and it will bring a lot of critical security challenges. So I think security is at the center of, irrespective of whether we are using blockchain for cryptocurrency or we are using blockchain for any other system across nation, we do need to come up with effective way of ensuring security. So do you see that we have an effective way, or there are efforts emerging or initiatives emerging from across nations that are focused on ensuring the security of blockchain and all its components?
Well, as you were thinking, as you were speaking, I was thinking about how the blockchain principle is what it is, and then the first application of the blockchain principle was currency. So you can think of the currency as a very successful. I've sometimes described Bitcoin as a really successful science fair project. Uh, there is a demonstration of blockchain, and in my mind, it's no coincidence because the simple ledger of a currency system is actually the simplest application I can think of to demonstrate what blockchains really do. And there are certainly concerns at the edges because, for example, what an institution, treasury, or what an individual does with the retirement is entirely different from what an individual does with pocket money. Uh, and so some should be very hard to get to, and some should be very easy. And if an individual walks around with their life savings in their pocket, it's just trouble waiting to happen. Uh, and not everybody wants to do currency, and that's okay. That's not what blockchain is all about. Um, it's just the a fifth example on the business side. Key management process will go a long way to securing things. Um, for the average person, say high net worth individuals, maybe they were lucky enough to be minors in the early days, they just find themselves sitting on a large stash. There are some fairly advanced uh, processes that one can employ at home to have a good answer for things like air gapping the key and burying the key away, and what happens if the key gets destroyed, and all the edge cases of that nature. So it can be pretty advanced. Really, I don't. I always go back to my mom. I really don't want my mom to run out and buy a whole pile of Bitcoin. I really don't want her to be responsible because um, the banking is good at custodianship, And in fact, an interesting move is JP Morgan has, if I'm not mistaken, the custodial service for people with a substantial amount of cryptocurrency. They could be minors. They could have done fundraising through an ICO. All kinds of reasons why they have so much. Uh, JP Morgan is offering a custodial service, which is basically saying, back to the traditional banking system, you can deposit here where it will be safe. You don't have to be,
Yes.
you don't have to pick up in a sweat because you're not quite sure where the private key is.
Yes, very true. Very true. I mean, the point that you made, that what is blockchain all about, I think that itself is a 1 hour discussion. Hopefully, we'll address that topic some other time. But what would you like? You have been actively working in this field, and you have seen the strengths and weaknesses of all the initiatives. You have seen the strengths and weaknesses of the current state of blockchain. So, having seen all that, having a good understanding of what blockchain is and where it's going, what are the trends, what would you like to tell our global viewers and listeners, and especially those young minds who are trying to make a difference across nations to try to solve some of the complex challenges facing their nation using this very transformative technology that is blockchain?
Well, I would really like to see more people involved in, I would call it a societal level discussion, not just technologists, not just politicians, not just, but everyone. Uh, Start thinking about the implications of technologies such as immutable data and unstoppable logic, and just exactly how do we think things should be structured? What is the ethical and proper application of this technology? Um, uh, I should say, most people can agree, privacy for me, transparency for thee, but that will never work. So how are we going to reconcile legitimate individual libertarian sort of concerns with practical law enforcement legitimate concerns and a whole pile of other concerns that need to be solved in terms of prioritization of society wants, because a lot of um, construction oriented questions start with what exactly are we trying to build? And this is basically the machinery of society that we're all going to end up living inside. So I think we should talk for those thinking of getting into it. Uh, I would say getting into blockchain is difficult, uh, and there's considerably more demand for blockchain professionals and talent. It's so difficult to get into this. An upgrade listener to certification, which is the boot camp with B9 Lab. Uh, they do both developer and professional strategic level training for decision makers who maybe are responsible for a budget, R&D organization, uh, and, uh, and also from a hiring standpoint, that this stuff is volatile stuff, and it needs to be treated like other safety oriented industries have learned to treat hazardous materials. So I would say please do recognize developer certifications from organizations like B9 Lab. And no matter what you do, if you want to experiment at home, if you want to build it yourself, that's okay too. But get all your relatives to pitch in and buy a security audit.
Very true. Good points and good suggestion and good advice, forward looking. So thank you so much, Rob, for participating in Risk Roundup today. We appreciate your thoughtful insight on the complex challenges facing blockchain initiatives, applications, and technical standards. And our global viewers and listeners would benefit tremendously from the understanding you provided on the technology gaps and vulnerabilities that needs to be effectively addressed for blockchain to be widely adopted. And even if a single blockchain initiative benefits from the discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that.
Thank you so much for having me.
Wonderful, Rob. So, Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence and transformation happening across cyberspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. And it's not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security. So, if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup webcast or hear the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jay Shree, host of Risk Roundup, signing off. See you next time. Thank you.